Hello everyone, today is January 20th, and this is a look and discussion of the upcoming weather this week, including the severe potential next Tuesday. Now I know it feels like in basically every single video, severe potential is all I have to talk about, but that's just how it's been this winter. As we go into Monday night and a Tuesday morning, notice how those dew points begin to creep up along with the temperatures. Tuesday will be the day of our severe weather threat, and you can see how our winds take a hike when we get there. These increased winds and their eventual rotation to southerly will bring in all that moisture, and that is where our severe weather threat will come in. By Tuesday morning, before the warm front even crosses our area, you'll notice that rain chances become likely with thunderstorms possible. Like I've mentioned, Tuesday is the day that we might see severe weather, and I'll explain why once we get into the models. But one thing that I can show you is these winds. These winds will be incredibly strong. You can see sustained winds about 25 to 30 miles an hour. Gusts will be up to 40, maybe even up to 50 miles an hour once we get closer to the event, and we'll see how that goes. But those strong winds will encourage all that moisture into the atmosphere and will also create high shear values across the area. However, this threat won't last too long, as by the time we get before midnight on Wednesday, temperatures fall again with another cold front. As we edge into Tuesday, notice how temperatures begin to warm quickly and that surface flow starts to come out of the south again. This is the GFS on Tuesday, and many models agree that this is a scenario that is likely to occur. Once the warm front crosses at some time around midday, the environment will be prime for storms. And not just any type of storms, but supercells. When we look at the storm system causing it, it's pretty clear to see where that is. A massive trough out to the west starts to move into our area and strengthens well over our area. This trough will be carrying our severe risk. Now when we look at severe events, typically the shear is what causes us to have limiting problems. However, in this situation, our mid-level winds are actually doing very well. In the last events, we saw wind speeds of about 45 knots at this level, or 50 miles an hour. In this situation, we have wind speeds of up to 75 knots or 85 miles an hour at this level. These speeds are significantly better than what we saw on any other event. But the most impressive part of this event is the low-level jet, or the low-level wind speeds. Take a look at these values. You have upwards of 60 to 70 knots in this area of low-level jet winds. That corresponds to 70 to 80 mile an hour winds just off the surface. Due to the low-level winds being so fast, that's the reason why we have such fast surface wind speeds in the first place. Even outside of any storm, winds could get really gusty. We could see gusts of up to 50 to 55 miles an hour during this time frame. Not to mention significant turning with height, as our surface winds are out of the south-southeast. With that, our mid-level winds are out of the southwest. This creates that speed shear and that turning in the atmosphere needed for supercells. Now I've already shown temperatures, but this is our dew points. While the highest moisture content will stay offshore, middle 60s to upper 60s dew points will definitely do good for your numbers. We could do better with the 70-degree dew points, but even if we don't, there's still high potential with this. Now, a first glance at our energy or our CAPE values in the atmosphere, you might think that they're not really good. However, one thing I do want you to recognize is that this is a global model. A global model has a lower resolution than any other model. For things like CAPE, it's a necessity to have a higher resolution model so that you can get things better organized with this. So in reality, I would expect that these 500 to 1000 values would end up being around 1000 to maybe even 2000 by the time we get to the HRRR. However, those models are just not quite in range yet. With all the ingredients in place, our supercell composite values max out between 7 and 8. With a lot said, there's a lot of ingredients that are coming together in this situation. It's very understandable to see why the model would output such higher numbers. For now, we're just going to keep a watch on the severe threat, as we are too far away to really tell the specifics on the storm coverage and stuff. Keep updated, as I will have more information as we get closer to the severe weather events themselves. Enjoy your week, like this video and subscribe to my channel, and I hope to see y'all in the next video. Thanks for watching.